Hello everyone, today you're in for a treat. I'm bringing you along with me in China to see the Phantom 2.0 production, but also the 2.0 Beta Stellar production, and you're gonna see the performance are crazy. So let's go. So here we have the raw material. We're looking at the stem of the Phantom 2.0, not yet cut at all. So you can see it looks like this. This is what it looks like when it's out of the extrusion. And then when we CNC all the little parts, it looks like this. So we're gonna CNC the opening for all the welding on the folding mechanism, upper assembly. We're gonna CNC the opening in the front for the stem light, for the cable brakes on each side, and then for each screws that's gonna link it to the handlebar. So you can see just for the stem, there's quite a lot of operation CNC-wise to make it like this. We have the new folding mechanism extra safety. So the little latch we had on the side, we have the folding hook as well here. All of these need to be polished, treated, painted. This is really the raw material. We have some parts for the city, for the production that's gonna happen. You see the swing arms here. And this is what it looks like when it's raw, extruded. So let's say we're gonna make a stem. It's gonna come out this long. And then we cut it in smaller parts to make the stems that I just showed you before. Here we have the swing arm. So you can see again, this one came out of extrusion. Then we CNC it, and you can still see all the marks of the CNC, passing like this. Again, it's gonna be polished and then painted. When it's coming out of the extrusion mold, it looks like this. Then we cut it shorter and it's gonna look like the one I just showed you. Here you can see the front fork. So earlier we saw the rear fork. This is the front one that we have here. And you can imagine all the operation in CNC to make all the opening, the angle, just this, it's quite a lot, but it's worth it. We continue. We have some more parts for the folding mechanism that you see here. So we have the upper part and the lower part. Again, you can see the beautiful CNC job done inside, like this. We have the folding mechanism latch, like this. Here, we have the tool that we do for the city. The old tool, we're adding the pin, to undo the direction. This is no longer needed. We replace it by nice nut that I'm gonna show you inside. This is a big improvement we're doing. Usually we receive the materials like this, It's gonna be wrapped in plastic, separated by cardboard, and it works fine enough because it's gonna be painted and polished after. But we think that we can still do a better job at protecting it, and that down the line on the assembly floor, there's gonna be less scratch, less dent on the metal. So this is what we're doing now. This is our new packaging that we're going to be introducing. So you can see it's cut out to fit. This one is all the stems. So we're going to fit each stem there, and when we transport it between factories, between the painting factories, our factories, it's going to be better protected, and it's going to result into a higher quality and a higher turnover when we do production. You can see here, it looks like this once it's inside the box. So we try to take care of it just as much when we deliver it to you that when it's being assembled, and having this process of taking care of it from A to Z is going to incite employees too to be more careful with it. And this is how we put the bearings there. You can see that the bearing of the cup is much tighter than before. It doesn't move at all, so that's a success. Here we're assembling the folding mechanism. And there's a new safety on it, right? The one on the side here, that when you open it, you need to flip this up to be able to fold the stem. And we are realizing that some of them are way too hard to move, So if you open it, it would be jammed like this. So we need to revise the tolerance to make it looser, to feel like this, So pretty easy to do, but annoying. So one of the improvements we see we can do is to remove the rear plastic cover. You need to remove the suspension first to be able to pass it. And that's going to be annoying if you need to replace the LED strip or just work on it. So what we're going to do, we're going to remove this part here. So it's going to be like this. So now you can install this and remove it with the suspension still being installed. Now we revise the LED strip to be stuck to the plastic, so the diffusion is always the same. Before there was no back adhesive paper, so the diffusion when looking at it was not constant. And also now those strips you can see are divided here, so when they fold it's not going to be a dot like in the middle ruining it. It's really made for the rear plastic part. So right now we're assembling the headset of the Phantom 2.0, so we're going to look at it. We have the headset that we start with, the part. We already assembled the headlight and the hook here with the magnet holding like this, and it's being done at this stage. Then we focus on the handlebar itself, so it's a classic handlebar you see like this, and we're going to be adding the throttle, the brake handle, the covers, and route all the wires inside of it, as you can see. At this stage, we're going to mount a handlebar on the headset, and they're going to be adding the front cover that we have here. We add everything, and at this point, you can see all the connectors are loose. They're not connected. We have all the quad locks to lock your phone on the headset, and we have the plate under it with the NFC already in it. So we're just gonna connect this inside the headset. And once all of this is done, we put the top plate with the display, we connect everything, and this is what it looks like. So for the suspension to be smooth when you jump on the scooter, we have bearings inside the swing arm, right? And we're realizing that the bearings goes here, that when we push the bearing in, now being done with a hammer and a special punch, it's actually pressing the whole surface, and some of those bearings don't feel quite right. So we're going to be replacing this whole process with a hydraulic press to press them in. Ideally, it's going to press on the outside of the bearing so it stays smooth and all thread as it should. So one of the issues we are seeing is passing the wires inside the deck, like of the front motor or the COM cable. And the wires goes inside the neck, come here, and they go on this side of the body, which is going to come out here. And this is very difficult to pass multiple wires at once there. So what we're going to do is just make this hole bigger, so you can see here the before and after, and this is gonna boost the production by 10%, we think. Just that little thing here. All right, so now that we corrected some of the processes that we saw that could be improved and improve some tolerance as well, now we are finally ramping up production. And again, this is always when we find other things we could improve, so we make sure to take notes of it. But overall, this is really when the production picked up and we were able to produce a couple containers to finally be able to ship them to you. So it was very exciting to pass from 2 units out of the line to hundreds of them. Alright, so we have our first unit out of the production line, and now the big question is how waterproof is it? We have a little shower here. We're going to try to spray it really from every angle. This is a very light pressure jet. Obviously when we do IP66, it's at the lab. We put it on the table with a high pressure jet that spins the scooter for a couple hours. So this is just to give us an idea if there's something obvious that we missed. We did the headset. We're gonna try to make it go inside the LED stem and the headlight. Here. And where the neck is, and those lights. You know, this is really easy for the water to get there usually, but we did this one really tight, so I think it's gonna be good. So now we put water all around the deck to see if it got in. Now we're gonna open it up and check out if there's water inside the deck. So let's check it out. What the f***? Alright, so one of the tests we always do to test individual components to see if they're waterproof is just to take them and dump them into the water. So today we're gonna try the new Dot 2 display that is fully covered with epoxy, so that should help. You can see here like this. We're gonna have the stem lights, we're gonna have the body lights, the rear brake light, we have the light box, which is also obviously waterproof, the turning signal. So we're just gonna put everything into the water and make sure that it's actually water resistant. So we can see the lights are not affected and the brakes are flashing because the brakes were applied. So you can see the display, well, it's flashing, but that's normal. It's because the components are not connected, but it's fully waterproof as well. You see everything works as intended. And now we're gonna lower it and put the controller as well. So you see there's really no question that even if water gets into the body, well, everything individually is waterproof. Now for the big test, we're also gonna drop the battery inside the water, so let's see what happens. Okay? So again, as you can see, even if there's water getting inside the body of your scooter or in the lights or wherever, everything is IP67 or maybe even 68 at this point. So you should be fully covered against any type of water damage. So now we have a 140,000 repetition on the throttle and they still feel great, still feels butter smooth. And again, on our throttles, we do 500,000 repetition usually. We're testing the charger, we're testing the battery, we charge it, discharge it, a number of cycles, and we also do the rig testing. For this one, we aim to do 10,000 kilometers with 220 kilos on the scooter with 3 centimeter bump. And this equals to millions of hit on the front neck, the front wheel. It's very an abuse on the scooter, and usually other scooters we tested only do a couple dozen or 100 kilometers like this. This is a new toolkit. We have the tool to redress the disc if bent, the big tool to remove the wheel with the socket there. We have all the screws, air valve extender, a set of stickers now, the Allen keys, and the air pump. All right, so we have the first unit out of the production line right here, the Phantom 2.0 52 volt, and we're gonna try it against also the first unit out of the line, the Phantom 2.0 Stellar Edition 60 volt. You can see the nice caliper here. So let's see an acceleration. How does it compare? So now I have the Stellar and I'll show you how butter smooth the throttle is. I'll be driving it in one hand, which you should never do, while drinking a coffee and being in Ludo mode. I don't know any other scooters you can do that. And this is the same mode that I can still do this. It's magic. So after that, it was time for packaging to put the scooters inside the box, do the final QC. What a trip. It's great to see that we're getting better and better at production. And you know, there's a lot of things we skip in this video, but it was a world of difference if we compare it to, let's say, the Pro production that we had or even the Apollo Go production. This one was just so much smoother. So it's fantastic to see. I'm proud of my team and I'm excited for the next trip. So there you have it. As you can see, the production was a success, and at this moment the Phantom are already on the sea on its way to you. If you pre-ordered it, thank you so much, and if you haven't, go check out our website and pre-order it to make sure to secure the best price you'll ever get on them. Thank you.